Hey folks, and welcome back to Open Analysis Live. So today we're going to do the second part in our tutorial series talking about how to fully reverse engineer a piece of malware. It's an IRC bot. And in the first video, if you haven't watched it, I'll link it in the video description below. Basically what we did was we prepared the IDB for analysis. So we decrypted all the strings, we labeled all the dynamic imports, and now we're ready to start analyzing. Today it's going to be all about annotating that IDB. So we were going to talk about how to identify the code patterns that we see, how to build structs, how to use the debugger to basically verify the different data types that we're seeing in the structs, add it all into IDB so that the IDB code begins to look like C code so we can actually read it and figure out what it's doing. So that's what we're going to be doing today. Again, it's a long sort of in-depth reverse engineering tutorial. These are sort of meant to give you, I guess, a more realistic view of what it's like to really reverse engineer something. Hopefully that's not too boring. I know that some of these are tedious at times while you're trying to label stuff, so hopefully you guys bear with us. But again, there's been so much demand for these that I just kind of wanted to see how it would do, see how you guys would react. So we're going to give it a shot here. Now, before we get into this, again, a word from our sponsors, which is us over at UNPACME.
UnPackMe, a malware unpacking service from Open Analysis. Expose the malware before it exposes you.
If you haven't checked it out and you want to unpack some malware, head on over there. It's free and hopefully it's a useful service for you guys. Okay, so where we left off in the last video is what we see in our IDA here. So we have basically split screen. We have our disassembly here and we have our decompiled view here. I am using the Hexraze decompiler, but again, you can use the free GIDHUB, whatever you want to call it, version if you don't have Hexraze. But again, we're going to be using Hexraze. The process is the same. The graphical user interface is different. So what we're going to do here is we're actually in the start, the main function that is called when this binary is executed. We've labeled everything, hopefully. We've decrypted all the strings, hopefully, and we're ready to start analyzing. Now, where I left off in the last video was we saw that this function was actually being used to set the debug privileges for the process. This is just basically trying to elevate the privileges if they can. This function was used to decrypt the strings. You'll notice that I'm using an MW underscore malware, basically prefix to all of my labels. If you haven't watched our video on BinDiff, go and check that out. I'll link that again in the description below. That's why I'm using the MW so that I can easily use this to map to future IDBs if I want to, using that trick that we show you there. So here we go. Let's start analyzing this. We have a load library function for kernel32.dll, so that's putting the pointer to kernel32.dll loaded here. We move that into var1. I'm not going to label these variables up. There's not really much purpose because we've actually already labeled all of the APIs that have been resolved, and that's of course why you would load, kernel32.dll, at least in this case it looks like that's why. So I'm not going to bother doing all the nitty-gritty stuff. I'm just going to label sort of the big functions so we can get an understanding of what's going on here. Okay, so now that we've resolved these APIs, we come into this little loop down here. We use the API create tool help 32 snapshot, which actually has nothing to do with tool help. What it does is it gets a pointer to a linked list, I believe, or a list basically of all of the running processes, and then you can use like process 32 first, process 32 next to basically iterate through all the processes. If I have some art, I'll like throw it on the screen for you guys here so you can see what I'm talking about. We've talked about this in some of our unpacking videos. Anytime you see this in malware, you pretty much know what they're trying to do. They're trying to walk through all the processes that are running on the host and figure, whatever, identify a process or something. So I wouldn't be surprised to see a loop here, which I do. Of course, there's our friend, process 32 next. So it looks like what they do is they do this create tool help snapshot to get that list. They grab a pointer to the first process. Then they use this for loop to iterate through each process in that tree. ZW right memory? No. That is not right. That is our pointer to the list. Okay, so you can see this is a little bit confusing here. I went over this in the last video. They are reusing variables. So somewhere later on, here we go. They actually reuse that variable and they turn that into an API call for ZW write virtual memory. So we're just gonna have to keep in mind that here it's actually the pointer to our linked list here. So I'll just say ZW write virtual memory. is dual use. And in this case, it's the pointer to process list. Okay, so what they're doing is they're looping through that process list, and they're doing a string compare. What are they doing a string compare with? Explorer.exe. So what are they really doing here? They're looking for, okay. And again, I'm going a little bit fast, but this is because this is a pattern that we see in tons of malware. It's very basic, basic. I'll try and keep this nice and PG for us. So it's very basic of them to kind of see this pattern here. So they're looking for explorer.exe. What do they do if they find it? Here's another dual use variable that we found in our previous video. So in this case, it's actually open process, not virtual alloc. So what are they doing? They're actually opening that process. They're opening a handle to explorer.exe. That'll be the handle right here. So I am going to rename that exe. And then what are they doing here? If they succeed in getting that handle, they just break out. So they pop over to this label here, which I'll rename. Okay, so they just break out. So when they break out, they also helpfully assign it to v93. Do they use v93 anywhere else? Yeah, they use it at the bottom. So let's rename that as well. So that's also going to be var handle the duplicate, so I'll just put one there. Okay, so this whole piece of code here is basically, like I said, something that we see a lot in malware. They're going to loop through every running process on the host, looking for explorer.exe. Once they find explorer.exe, they open process, they get a handle to it, and then they break out of loop. All right, so what do they do next after they get that handle? They close that handle to the process list, so that's fine, that's just clean up. If they got a valid process explorer handle, we come in here and do all this stuff. If we don't get one, what do? We do nothing. Okay, cool. So it looks like they need a handle to process explorer.exe, otherwise this malware is not gonna work. So there's our first little thing to note down in our notepad. Next thing to take a look at is what are they actually doing with it. Now, if I had to guess, I guess they're probably injecting something into it. We did see that ZW write virtual memory, that they're actually creating that API call, they're resolving that, so they're probably gonna write something into it. Just a guess though. So here we go, let's see. First thing they're doing here is they'll grab a Git module name. So that's actually and they're passing a null handle. So they're actually getting their own file name here, and they're gonna save that into var malware file name. Saving that in there. What are they saving it there for? I'm not sure. Maybe they use it later on in the program or something like that. What I'm focused on here though is what they're doing with that explorer.exe handle. So it looks like they're resolving some more APIs. Let's see, what's that string? This is the I love you virus key that we saw. So they're copying that into this pointer here. So I'm going to rename not pointer into this variable. So I'm going to rename this variable, even though it has, again, this is going to be wonky because there's a lot of variable reuse. So we're basically going to have to go procedurally through the function and rename stuff as we go, because again, the variable reuse is going to make it confusing. So even though we use that process32next variable just a second ago in the code above, we're going to have to rename it here so we can keep track of what the heck this is. So what is this? This is a pointer to that I love you string. I wonder if this is like a pointer table to those strings. I'm going to just press DDD to turn these into, yeah. So I'm basically turning these into D words. And each D word, it looks like, points to the address of the strings table that we decrypted in the previous video. So if we pop over to, I'll just double click here, so we can see all these strings have all been decrypted. And this table here is a bunch of pointers to these strings. So what this looks like to me is this looks like some sort of strings table that's going to be referenced somewhere later on in the code. So what I'm going to do is I'm going to just rename this very first pointer as the string table. So I'm going to call it pointer to string table 1. All right. So what are they doing here? Let's rename this as var pointer to the string table. Okay, so if they get a pointer to it, they dereference it to check whether it's null or not. In this case, we know it's not going to be null because those are actually strings. They grab the string length. They do a virtual alloc for that string length in the process that they just got the handle to, the explorer.exe process. So they're actually allocating memory in that remote process now, not their own process. And it looks like they are probably, that's the string length, they're probably going to write that string into the remote process. And this is a string, not code. So if I had to guess, what they're probably doing is they're probably going to write some data into explorer.exe. Then they're going to inject their code into explorer.exe. Then they're going to pass execution into the injected code, which is then going to expect that data to be in explorer.exe. So I did take a quick look at this before, and I think that's what they're doing. And then looking at these API calls, it definitely looks like that's confirmed. So what this means is our reversing is going to be a little bit more difficult than just a straight up analysis of the code, because we are going to have a lot of memory references in the code. So let's see what they're doing here, but we'll just keep that in the back of our mind that we might have to basically create some pointer tables or some
coronavirus
some structs. Okay, so they're creating that memory in explorer.exe. They're grabbing the string length again. If it doesn't work, where do they go? They pop over to this label. Oh, okay. So this label definitely has a purpose. This just closes that explorer.exe handle and exits process. So this would be if something fails, it looks like this label is where they jump. So let's name this as exit. So we're definitely not going to take that path. We're going to assume that it works. So they get the string length of that first word. Then they write that first word into the memory that they've just allocated. So I'll just rename this variable so you can see. So this is new mem in Explorer, and this is the string length. So you can see here they're doing as db write virtual memory. The handle that they pass it to is the handle for explorer.exe. They're writing in
coronavirus.
Oh my god. I had Thai soup with garlic and chilies for dinner, and now it's going to be a lot of editing, I think. Okay, they're writing in the newly allocated memory, so that's where they're writing to. And they're writing in the first string in the string table with the string length that they just found for that string. And I'm gonna see, yeah, there's a nice while loop here, goes here. And what do? They write all the strings into memory up until all I see is U. And is that the bottom of this table? I think it is. Yep. Here's the beginning of our table. So the all that I see keyword is the end of the table. So I'm just gonna make a comment here okay, cool. So this we can now label as write all strings from str table 1 into Explorer. Boom. Okay, so that's our whole chunk of code right here. So what do they do next? Next thing they do is they check if this is something. What is this? This is another pointer to a string. Another string. Maybe this is another string table. So this string is a bunch of spaces. Okay, all right, maybe that's used somewhere in the code here. There's another string with not as many spaces, and then another string with a whole bunch of spaces. Okay, so let's label this up too. So we'll name this pointer to string table 2. And again, if we press DDD to turn these all into D words, yeah, so we can see the string table has 3 strings in it, a bunch of spaces, and then this now I am far, far away.com. Okay, cool. Good job.
Coronavirus!
All right. Oh, and I've lost my place here. Just add a little comment in there. Make sure that they know this is the end of the table. The string table, right? Okay, so they check if there is a string table 2, which again, we know that there is. They grab the address to that string table. That's what the ampersand stands for. They copy that address into this variable that we were using for string table 1. So now let's rename it as string table 2. We have another while loop. How much you want to bet they're going to write another bunch of strings in there? Let's see here. They grab, all right, okay, so there's just 2 pointers to the strings table. So here they grab they dereference it, so that's the actual string. They grab the string length. This is the var str1, 2. All right, so now they basically they allocate the space based on the new string length. They're definitely gonna do a write in here somewhere. And then there's a write, so they're writing it in. Now, do they do anything else here? No, nothing really of interest. Okay, and then this is the break here. Not a break, loop complete. Okay, so what are they doing here? they are writing in str table to explorer.exe. Okay. All right. So we have this. Where does that end? It ends here. Okay. All right. So this whole block of code is just writing in the strings table 2. Once they've completed that, they move on down to loop complete. Ooh, lots of interesting API calls in here. So what are they doing here? Okay, so they're taking the address of this null subfunction and they're subtracting the address of this function. And then, well, they're allocating the difference and then they're writing it in that much code. Okay, all right, so let's see where this null sub is. Oh, it's at the end of the text section. Okay, this is some very sloppy, sloppy trick here. Okay, so we don't have to care what the function is. We just care that it's the address 403013 and that address is at the very end of the text section. Text section is where all the code is in this binary. So if we look back here at what they're doing, they're basically saying get the size of the function, and they're not really getting the size of the function. What they're doing is they're just getting the size from where the function starts in the text section to the end of the text section. So they're going to be copying a whole bunch of extra stuff, but I guess they probably don't care about that. They're just basically trying to make sure they get the full size of the function in there. So this is kind of sloppy. I guess there's probably other ways you could do it, but maybe this allows them to do some compiling. They don't have to find other ways to get the function size. So basically what they're doing is they're getting the size of this function plus a bunch of bytes and they're assigning it here. So again, these are reused variables. So var function size, and they're allocating that size to explorer.exe. So here's where we're probably going to see some code injection. Then they actually write that function into explorer.exe, including extra code, again, that they don't need because they are just writing right up until the end of the text section. Do they do this a bunch? They do this a bunch of times. This is so sloppy. So basically what they're doing is instead of just writing the function that they want into explorer.exe, they're writing like a bunch of extra code each time. Anyway, it's bizarre. Okay, so anyway, good for them. They're doing some injection here, and it looks like all of these functions are going to be injected. So I'm going to do something. I'm just going to pre-pen them with inj, just so that we know that these are injected functions. So when we go to analyze them, we'll know that we can't analyze them inside the context of this binary, and we need to analyze them inside the context of being injected into explorer.exe, because that's where they're going to be run. So let me just rename these. Okay, so we got them all labeled up, and we can see that they're just pulling the same trick again and again and again, right? So they're getting the size of these functions, they're allocating that size into explorer.exe, then they're writing in that function plus the extra bytes, and they're just continuing to do it again and again. And so here, what they're doing here is they resolve a whole lot more APIs, which we didn't see them use, and there's hardly anything else left for them to do here. So they must inject these APIs. So they must do some sort of dynamic resolving prior to injecting into explorer.exe. So let's see what we've got here. What is this wait for single object? So that's an API, but okay. So this is a different sort of technique, something else that you might see sometimes, where instead of resolving an import table in the memory of their own process, they've resolved all the pointers to these APIs as local variables or variables on the stack. Then what they can do is they can write those pointers into explorer.exe, and the APIs will be resolved basically by doing that. So it looks like they've resolved them here, and then it looks like they're writing all of them in. So this is passing the address to ZW write virtual memory into explorer.exe, the address of the very first stacked variable, and they're writing in basically all the stacked variables there. So in addition to having two string tables written into explorer.exe that we're going to have to find, we're also going to have to find a giant array of resolved API calls. Okay, so that makes makes our job a little bit easier. We know what we're gonna have to look for here. And what else are they doing here? Anything else exciting? So they create remote thread, I call it here, and they pass in the address. That'll be like the new entry point, I guess, in explorer.exe, or it'll be the entry point where they start their thread. It's not a new entry point, but it's basically where their code begins executing. So we wanna map this back to the function that it came from, so we know which function begins the execution. And so the way to do that is to find which one was written in here. The last one is right here. So 18 is this function right here. So this is going to be the malware inject thread. Okay. So that's the function that we want to start analyzing. So let's take a look at it. But like I said, there's going to be a bunch of data injected into explorer.exe that we don't have yet. So it's going to probably be hard to analyze. So I'll show you what that looks like.
Holy Jesus. What is that? What the fuck is that?
It's impossible to figure out what's going on here without having that extra data for context, right? It's just a whole bunch of pointer math pointing to stuff that we don't know. However, we can easily find out what it's pointing to and basically make our lives way easier, because we can see here that it's actually passed one argument. It's a thread that's being started. So this will be like the context for the thread, or a memory object which it can operate on. And you can see that all of these pointers reference that object. So what we can do is we can go back, and this is actually documented in create remote thread. The argument right after the entry point for the thread is the context, or the memory object that you're passing to it. And it'll say like thread arguments or whatever. Actually, if we just pull it up, we can see. So you can see here is the thread start address, and then we have the parameters that we're passing it, which in this case we know to be an object in memory that they are then referencing. So what we can do here is we can open up our debugger, and instead of having to basically track back this memory, which we can do, it's not too hard, we can track it back here and figure out what was written there, but it'll be faster and easier to actually conceptualize if I just open up a debugger, put a breakpoint on create remote thread, break on it, and then take a look at the memory that they're passing as that parameter. And I'll show you guys that it is actually very simple once you see that to figure out what those structs are. And then we'll create the structs in IDA, and you'll see it'll make these functions much easier to understand. Okay, so we've got our debugger here. I just have Process Explorer running, which I pretty much always have running, just to make sure I understand what's going on. I'm gonna turn off the network adapter, disconnect it. I'll see the little thing disconnect here, just in case it does something crazy. I'll load this up in our debugger, x64dbg as per usual, load our sample in here, do a BP on create remote thread. All right, set that breakpoint, run until we get to the entry point, which is always set, run until we get to create remote thread. Then we'll look at our arguments, which are on the stack here. So that's a return. This is the handle. This I don't remember. This is the entry point to the thread in explorer.exe. I'm going to show you this in a second. And this is the memory object that is passed in explorer.exe. So in order to see what these look like, what we need to do is we need to open another x64dbg here, and we need to attach to explorer.exe. All right, now that we've attached to explorer.exe, keep in mind, explorer.exe is running the window manager for Windows, your VM. So a lot of stuff is going to stop working since we attached a debugger to it, but the debugger will continue to work. So just keep that in mind. Okay, so now that we've attached it, what we want to do is want to look at these addresses. So let's look at, we'll come into the dissembler here, Control G to jump to 3A8. 3A8, boom. And that was a memory object. Now let's look at the code first. I'd like to see the memory object in the memory dump here. So let's Control G and we'll go to 39734. Okay, so this is going to be the entry point for our thread. Okay, so this is where the code is going to start executing once we return from that create thread. And let's just double check that we're on the right path here. We can see this code, push EBP, move ESP EBP, and then sub 3A8 to add room for your stack variables or your local variables. So 3A8, let's just make sure that this little prologue exists in the function that we think is the entry point in IDA. So let's come back here, and we'll go to, where the heck was it? Was right here is the start. And then let's look at our assembly. Does that look right to you guys? All right, we're right. So we've done one thing so far, which is to confirm that that function is going to be the very first code that's running in explorer.exe after the injection is complete. Okay, so like I said, I'd like to take a look at the injected memory object or the parameter to the thread, which is this address here. And I'd like to look at it in our hex dump here. So let's Control G in the hex dump, and we'll do 3A8, 1, 2, 3, 4. Jump to that. We can't really see very much here. I'm going to show you a trick in x64dbg. So just right click and change these two addresses. And this will actually show you, it'll represent them as pointers. So we can see that this pointer, so there's, it looks like there's 4 pointers in this memory object. And the first one, if we follow it, follow dword, is the import table, or the dynamically resolved imports. So here we go. This looks a lot like, wait for single object stuff. That looks a lot like if we come back into here, right? Looks the same. So basically what they've done is they have injected this table into explorer.exe, and then they have used the minus to go back. They have used this struct here to basically reference it. What's in the second pointer here? Follow dword in current dump. Interesting. I'm not really sure what these are. Follow dword in current dump. And let's see, this is like some hex or ASCII. Yeah, not too sure what this is here. Next thing on our pointer list here, I think these are probably the two strings tables that were injected in. So let's take a look at this dword in current dump. Yeah, those are definitely the strings. So these are all pointers to the strings table that was injected in. So that was strings table 1, I think we called it. And I'm betting that this is probably strings table 2. Well, we kind of know it. Yeah, it is. It's the two giant long spaces and then this kind of weird poem thing. Okay, so the way to make use of this in IDA is to create a struct that looks like this, so that we can represent these values inside IDA. Now I feel like in the comments we'll probably get some helpful tips on how to just copy this stuff out into a struct in IDA. I don't know how to do that, and it doesn't take too long to just create them by hand in IDA, so I'll show you guys how to do that first. So the first thing we need to do is create the initial parameter struct memory object, and we'll just make all those void pointers. And then we will build these tables, and we will basically fill them in as structures that are pointed to by those. And you'll see what I mean. It might sound complicated, but once I show you, you'll see. Okay, we know that there are 4 void pointers. That's the best place to start. Come back in here. Go into View, Subview, Locals, Local Types, right-click, insert a new local type. I can't remember the struct definition. Edit this. Yeah, there we go. I always forget the C definition for structs. All right, so, okay, so we're going to insert struct. We'll call it thread object, maybe inject thread object, and then we're going to make 4 void pointers, and this is going to be
D, motherfucker, D!
Import table, so this will be API table. The next one, I'm not sure what it is, so we'll just leave it as unknown. And then the next one is strings table 1, 1. And then the last thing is void star 2. Okay, save those out. All right, so let's pop back into our pseudocode here, go to the thread start, recast this, press Y to change the type declaration, cast this as the struct. Okay, all right. So our code is still unreadable, but we at least have some pointers here. We can see this is probably going to be the API table. This looks correct, so it looks like the API table with some offset is being used as a function call, so we probably got this right. So next thing to do is to add that API table as a struct, and then once we add it as a struct, we can change the initial definition of this inject thread object to point to that struct. So the way to do this, I guess I'm sure there's a better way, but the lazy way that I know how to do is basically pop over to our list of them here, highlight all of these variables, right click, create struct from selection. All right, now we have our struct. We're gonna name this as API table. All right, all the names have been imported in here. So what we can do is then we can go into our locals. API table is now showing up as a struct. We can come in here, we can edit our newly created struct. We, instead of being a void pointer, make it API TBL, make that an API table struct. Okay. And then we come back into our pseudocode, F5. Boom. Pretty good, right? Look, these are all of our API calls. So now this went from being completely unreadable pointer math to now, I mean, it looks a little bit messy because you can see the calls here, like the pointers, but basically you just have to look at the last thing. This is create directory A, this is set file attributes. You basically have a bunch of code now that you can read. Now you could go and sort of clean this up a little bit more, blah, blah, but I think this is fine, at least to get started. All right, next thing you want to do is want to do the same thing for those two string tables. So those are a little bit different. Those aren't stacked variables. Those are actually pointers in memory. So we're going to have to create our structs based on those pointers in memory. So let's go back to start here, where everything starts. Let's take a look at the string table that they inject. That's string table 2. So string table 1, string table 1. All right. So here's our string table 1, and what I'd like to do is I'd like to turn all of these into D words so that they pick up the fact that they're pointers. And I'm going to do it all the way down to here. Can't remember what it is. Is it like make D word? I think it's something like that. So this will be the start, this will be the end, is whatever this address is here, 0x, whatever. And the start is going to be the start of this table, way up here. Start equals 0x, whatever. For I in a range from start to end, and 4 bytes at a time because they're D words. 1, 2, 3, 4. Create D word of I. Is that going to work? Hey! All right. So there we go. I created D words that point to all these strings. So now I have a nice table that I can turn into a struct. There we go. Right click, create struct from selection. Boom. Okay. Man, oh man. And then we're going to name this as string table 1. Okay. And I think the first one, I had actually picked up the label in the string table, but it's not actually it's the I love you pointer. So let's go into our structures, name this as a I love you. All right, now we can fix up our structs in locals. You can see our new struct has showed up here. There's just what you can see me doing is I don't like to edit structures in the structure view in IDA. I find it clumsy and horrible. I like to just write the C code. So you can write the C code in the local types interface. That's why I keep on switching back to that to do the editing. You can edit it in the structs view, but it's horrible. The user interface for it is terrible. So let's edit this and we'll turn this into strtbl1. Okay. Come over to our pseudocode for our main injection thread. Of it, and we have both the API calls and we have the structs that point to the strings that are in memory. So now this is pretty much ready to reverse engineer. We're ready to start analyzing it. I'll just add in that second strings table so we can do that one as well. And then we're ready to start figuring out what this code does. Go to our local types here, edit this again, string table 2. Okay, come into our pseudocode, pop into our thread start here, F5 just to get the recompile going. And now you can see that all of these, everything has a label. We now can go through and analyze these. And if you're looking at something like a function call here, so we know that the context for this function is going to be injected into explorer.exe. So any function that it calls is also going to be injected into explorer.exe. So we would expect that they probably have to pass that context, the in-memory object with all those pointers, to any function that they call. So if we look here is a function call that pass A1, which we know is the injected thread object. And what we can do is we can come in here, Y to change the type here and make this inj thread object. Boom. We begin to label everything in the function based on that thread object. So you'll just have to do that for each one of the function calls in here. We'll see if there's some more subs, a few more here. So we can see here, they're passing in that v1, they're passing in a string here, which is kind of cool. We can see what that string is. So when we come into this function here, we're going to have to rename these types each time. So we'll have to change the type to the thread object, and then all of our function labels that we've put in here all show up. So we can see right away, like you could see when we came in here, you can't make any sense of that function. Now that we added the labels, you can see like immediately socket and connect. Obviously they're creating a connection, like a TCP connection. So it's super simple to basically go through and reverse engineer this. What I'm gonna do is, this has already gone on long enough for this portion. You've seen how to basically take that information from the debugger, confirm it inside IDA, and then label all those functions so that they have the right context as they would be executed in Explorer. So this is the second step in our reverse engineering tutorial. And then the final video will be a look at what the actual code does. So stay tuned for that. Again, these are long, in-depth tutorials. I'm not sure if everybody likes this. We'll see by the views in the comments. If you do like it, make sure to let us know. And if you guys prefer the other shorter sort of quick tip stuff, we'll try and balance it out. But again, we've been wanting to do one of these like long form videos for a long time. So here it is, and we'll see how it does. Okay, so stay tuned for next week. Till then, stay safe and keep exposing the mechanics behind the malware. Stay curious.
Well, I got 545 and it's 545. Gotta get a Whopper and a 40 right. Yeah, you know you fucking feel me. Yeah, you know you fucking feel me. Yeah, you know you fucking feel me right.